So this section right here is going to ask for end behavior of each function, right? So when we're talking end behavior, we're talking about what happens at positive or negative infinity, the big, 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 big numbers, right? So the only thing that really matters for the big, 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 big numbers is whatever that highest exponent is doing, right? So when you see a problem like this, you could use Pascal's triangle to fully expand this whole entire thing, right? However, for end behavior, the whole thing doesn't matter, right? It's only the one with the highest exponent. So if I were doing this problem right here, I would roughly think about Pascal's triangle, very roughly, right? And so what I would do is, I know I would have like 3x squared right here. And then I know I would have, you know, if I want to, I mean, I could do the 1, 4, 6, 4, 1. I could do that. And I know, I mean, for your sake, I'm going to write the whole thing out. In my head, I would shorten this up even a little bit more. But like I would have 5 to the 4th power, 5 to the 3rd power, 5 to the 2nd power, 5 to the 1st power, no 5 at all, right there. And then I would have the negative x. I'd have negative x to the 4th power, negative x to the 3rd power. So this one right smaller. I'd have negative x squared. I'd have negative x to the 1st power. I'd have no x's at all. I'm going to put plus signs in between everything here. Okay. Now I could deal with all of this, right? But which part is going to have the highest exponent? This last piece right here, this x to the 4th power, right? So I'm kind of ignoring all this stuff right here because it's not that important for me, right? But I do know negative x to the 4th power is going to be negative x times negative x times negative x times negative x, which will give me a positive x to the 4th. So I'm going to have 3x squared times some stuff up here, and then I'll have an x to the 4th there at the end, right? Which will give me, when I distribute that 3x squared to everything, it's going to give me some stuff that is not that important for end behavior, right? Plus 3x to the 6th power. We okay there? You could probably do all this, in, like the whole thing in your head, by picturing what's going to happen. So if 3x to the 6th is my highest exponent, then I am going to look, whatever coefficient I have, if it is positive, that tells me what the right side does. The right side goes up here. And then I have an even exponent. What does that tell me? Same direction. So this side goes up. So if I want to use limit notation to write this, I would say the limit as x approaches negative infinity of f of x is going to be, that means I'm approaching negative infinity, that's my left side. I'm going to get positive infinity as my answer there. And then I would say the limit as x approaches positive infinity of f of x equals positive infinity also. You just have to be careful with the sign right here, especially on this one where that x is negative, because if it was an odd power, so if we had like negative x to the 5th power, then your x would be negative, so it would flip everything upside down for that. So be careful and don't ignore the sign that would be with it, because if you have an odd power, then that negative won't just go away for that, for those. Okay, for number 8, I want to, again, roughly think about just what the highest exponent is going to look like for this. Now, this one right here, on the top, I've got x plus 3. I'm going to raise it to the 3rd power. My highest exponent, that x right there, gets raised to the 3rd power. And then you'll have x squared and x to the 1st and no x at all. But x to the 3rd is your highest power, right? And then on the bottom, so it'll be plus dot, dot, dot. We don't know. On the bottom, it's that last term, right, that's going to get squared. So, you can think about doing the whole thing if you want, but that last term, the negative 2x, is going to be squared, and then you'll have other stuff with it. And so we'll be looking at x to the 3rd power over negative 2 squared is positive 4x squared. And then there's other stuff here, but when we're thinking about end behavior, that other stuff doesn't matter. So remember, for end behavior for rational functions, we're thinking Bobo, Botno, eats CC. Bigger on top is not 1. That's the part that we're using, Botno, right? So we've got a bigger exponent on top. Remember that what we're going to do is we're going to sort of reduce this, right? Although I don't even want to use an equal sign because it's not exactly the same. I'm going to use an arrow. I would have, like, there's a 1 right here, so I'd have like 1/4. And I've got x to the 3rd over x squared, which is just going to give me x to the 1st power. And so this is not exactly equivalent to 1/4 x, but it's going to have the same end behavior as 1/4 x. So I'm going to look at my right side. I look at my coefficient. That is positive, so the right side goes up. I have an odd exponent, so what does the left side do? Down. Okay, and then you can write your limit expressions for that. So limit as x approaches negative infinity of f of x. That's your left side. It's going to be negative infinity. And your limit as x approaches positive infinity of f of x. That's your right side. That'll give you a positive infinity. So if you see something like this, you don't have to do the full Pascal's triangle. You can kind of scale it back a little bit there. Okay, questions here? That pulls, I know it's been like a long time. Make sure you still remember those rules for your end behavior. That's going to like keep coming back up there. All right, let's see. Do I need to do this? I think we can skip this factoring right here. I think it was just a little extra practice that I was throwing in. Let's talk about some slant asymptotes. Okay. When the degree of the numerator is exactly 1, so exactly 1, greater than the degree of the denominator, the function has a slant asymptote. So to find that slant asymptote, we can use long division to rewrite the equation in a different form. So if you have a function where you have like x to the 4th is your highest power in the numerator, and x to the 3rd is the highest power in the denominator, then that function is going to look something like this, where you have a slant asymptote. So you have a line that your graph is getting closer and closer and closer to, but it's a slanted line, not a horizontal or a vertical. Now this one also has a vertical asymptote as well. A lot of times you'll have a combination there. For that. Questions? All right, we need to be able to find the equation of this line right here. And to do that, we have to do long division of polynomials. Okay, so you did this a little bit in Math 3. I realize for some of you, Math 3 is very long ago. I will be very surprised if you remember how to do long division of polynomials without any assistance at all. In fact, let's back up. Let's use the space right here where I had that other problem. Let's just do one regular long division problem. Okay, like 4th grade kind of long division problem. Okay, because it's the same process. It's just way more complicated with the variables. So let's just do one right here. Let's say that we're taking 2,321, and let's say that we are dividing that by 5. Pick something I know doesn't go evenly on purpose right here. Okay, so remind yourself of the process right here. You're saying, oh, does 5 go into 2? No, it does not. So then you got to go over another digit. Does 5 go into 23? Yes. So what's the closest we can get to 23? Multiplying by 4, right? So we'll have a 4 right here. Then we have to do 4 times 5 gives us 20. We write that down below. So our steps are divide, multiply. That's what we just did. Then what do we do next? Subtract. We get 3. And then what do we do after that? Bring down. And we just go through that process over and over and over again. All right, so we bring down this 2. How many times will 5 go into 32? 6. 6 times 5 is 30. We'll subtract. We get a 2. We'll bring down. We get a 1. How many times will 5 go into 21? 4. Multiply. We get 20. Subtract. We get 1. Now, you have some options here on what you can do from this point. When you first begin doing long division, you'll put like R1, like you have a remainder of 1, right? And then later, you'll learn how to put like a decimal point there and keep going and get a decimal. But one that we don't really do that often in lower grades is that we can just write this as a mixed number. We can make it 1/5, right? So you got 4/64 and 1/5, right? If you keep going with the decimal, you'll get 0.2, which is the same as 1/5, right? For that, this is how we want to treat it when we're using variables, right? We're gonna write this as whatever the remainder is over the divisor, which is the number you're dividing by, right? So now that we've reminded ourselves of long division, because we all know we haven't really actually done that in a long time because we grabbed the calculator for it, and justifiably so. It takes a while, and the calculator can do it very quickly. Let's try it with some variables, okay? So just like with long division, whatever you're dividing by goes on the outside. So x minus 2 goes here. And then x squared plus 7x minus 5 goes here. First of all, I should be saying, do I even have a slant asymptote? Obviously, the directions tell you to find one, so I probably do. But I know I have a slant asymptote because my degree of my numerator is 1, and the degree of the denominator is, degree of the numerator is 2, degree of the denominator is 1. So that degree of the numerator is exactly 1 bigger than the denominator. So what I can do here is I'm going to divide, multiply, subtract, bring down. Divide, multiply, subtract, bring down. Whenever you're dividing, instead of thinking how many times will this go into, what I usually think is what times x gives me x squared, right? Ignore the minus 2 on the division part, right? So what times x would give me x squared? X. So x times x gives me x squared. Now I have to multiply this x by this whole thing right here, right? So I'm doing, I'm thinking I'm doing x times x minus 2, right? So that's going to give me x squared minus 2x right here whenever I multiply. And then, let me use a different color here. I need to subtract. So be careful with this. It's a little tricky. You're subtracting this, and you're subtracting this, but that second part is already negative, right? So really that becomes like you're adding there. And so x squared minus x squared is 0. That should go away. That first term should go away every time. If it doesn't, you did something wrong. And then the second term, I got 7x plus 2x will give me 9x. And then I bring down minus 5. Next, I have to ask myself. So I've divide, multiply, subtract, bring down, just brought down. So we're back to divide again, right? So I ask myself, what times x would give me 9x? And 9 is my answer, a positive 9. Right, so I'm going to put a plus 9 right there. So I divided. Now I'm multiplying. So I'm doing 9 times x minus 2. So I'm thinking of distributing that 9 right there. I will get 9x minus 18. So I divided, I multiplied. Now I need to subtract. Again, this happens where you get like a double negative, so you're really adding right there. And I'm going to get 9x minus 9x is 0. If that goes away, it should every time or you messed up. Negative 5 plus 18 is going to give me 13. I don't have anything to bring down. I also can't divide again because nothing times x is just going to give me a 13, not without using negative exponents, which we do not want to get into, right? So this is just my remainder here. So I could write this as 13 over x minus 2. So what we've done here is we have written this in a different form where if I graph my original f of x and I graph x plus 9 plus 13 over x minus 2, I'll get the same graph there. In fact, let's do it because I think it's helpful to see what this actually looks like. Although we're, of course, as always, running out of time. It's the story. It's the theme of this class, running out of time. Okay, so we got that one. And then if I do, I'm going to call it g of x. Notice here, I'm getting the same graph. Also, if I zoom out, you can see there's definitely a vertical asymptote at x equals 2. We would know that just by the denominator, right? So x equals 2 is a vertical asymptote. But watch this. Whatever this part, let me use a different color here. Whatever this part of the function is, y equals x plus 9. If I type that in, look what happens. There is your vertical asymptote. So this part, it doesn't really matter what the remainder is. This part gives you your equation for your slant asymptote. Okay, so if we do long division, whatever part we get here that's not the remainder, that's going to be our slant asymptote. Okay, does that make sense? And if you think about the numbers, like over here you got 13 over x minus 2. Well, as this number x gets bigger and bigger and bigger and bigger, then that part just gets closer and closer to 0, right? So it starts to look more and more just like the graph of x plus 9. Y equals x plus 9. So that is our slant asymptote. Let's try to get through the second one because it looks really scary, but it's really not too much worse here. And we're going to have 2x to the third plus 4x squared plus 3x on the outside. We'll have 6x to the fourth minus 3x squared plus 2x minus 1. And so you were just looking at those first numbers. What times 2x to the third would give me 6x to the fourth? So what times 2 would give you 6? 3, and then we need an x with it, right? So that 3x, I'm going to write it right here, over the 2x. The good news is you should never have more than like 2 steps here. It's not going to be one that takes you like half the page to do, because you should only get a line. You should get like 2 steps and then a remainder is what you should have happen. So if I multiply everything by 3x, you're thinking 3x times 2x to the third plus 4x squared plus 3x. Right here. 3x times 2x to the third is 6x to the fourth. 3x times 4x squared is going to be plus 12x to the third. Hold on, I got my... Oh, I've messed up. Because that's going to be 12x to the third. But what's above it? X squared. And that's going to be a problem. What should I have done? I needed like a 0x to the third right there. I should have added that placeholder. In my rush to get this done, I forgot. So like this really, like, think of it slid over, right? We got a 0x to the third above this. And then we got 3x times 3x is going to give us 9x squared. So everything's off a little bit from the way I wrote it, because I should have left myself a space, but it's not letting me erase here to do that. So if I subtract, this cancels. Here, I'm really doing that 0x to the third minus 12x to the third. That is going to be negative 12x to the third. And then I'm doing this negative 3x squared minus 9x squared, so that gives me negative 12x squared. And then I just bring down the 2x. Okay, then I'm going to ask myself, what times 2x to the third would give me negative 12x to the third? Negative 6. Now, do I really have to go any further here if all I need to know is slant asymptote? I can, this is like, because the next step is just going to be the remainder, right? Like, so I could stop here and say y equals 3x minus 6 is my slant asymptote for that. So you don't even have to finish the long division all the way. Now, if they ask you to rewrite it in the different form, you would. But you could stop here if they're just asking you for slant asymptote. So there is a delta math. I think it's got 5 questions. You need to do those 5 questions or spend at least 30 minutes on it. Okay? So if you get them all done quicker than 30 minutes, that's fine. If it's taking you longer than 30 minutes, you can quit. If you're actively working. If it's just up, it's not going to register as you working. So like if you just have it open in a tab, that doesn't count. But if you're actively working on it, it'll count you as time. Also, I had this here. I'm going to slide it to the next day. We're not going to take the quiz until Wednesday on this stuff. And because some of this you had to, or a lot of this you had to do remotely, I don't normally do practice quizzes, but I have put an optional practice quiz up here, which I need to change the dates on since I'm moving the quiz down here to Wednesday. But you don't have to do this. It's also not extra credit, but it gives you a look at what the quiz is going to look like. It pulls from the same question bank, so you'll see the same types of questions. That has due dates for tomorrow on it right now, but I'll change it so that it's not due till Wednesday. Although it's not really due at all. You don't have to do it, but it will cut off because I don't want you looking back to it. So delta math is your assignment tonight. The part B part for this, and